Okay, Algebra 1 fans, our topic for today, this is section 9-4, solve quadratic equations by factoring. So after this lesson, the goal is that you should be able to solve quadratic equations by factoring. Before we start, let me give you your joke of the day. What do you call someone with no body and no nose? And the answer is, nobody knows. Nobody knows. Okay. So a quadratic equation is in the form y equals ax squared plus bx plus c. Now we graph these, we call them functions, f of x, which is the same as y. So now how do we solve them? Well, zero product property. We're going to use this rule. For any real numbers a and b, if a times b is equal to 0, then either blank, blank, or blank. A and b are numbers. Okay, so on the side, here's a and here's b. And when you multiply them, the product is 0. So can you think of two numbers that you'd multiply where you'd get 0? And what you'd probably come up with, so for example, 4 times 0 is 0. You could say 0 times 10 is 0. You could say negative 55 times 0 is 0. Well, what has to happen is that one of these numbers has to be a 0. Okay, here's my number symbol. So either this one is 0 or this one is 0. When you multiply by 0, your product, your answer is 0. Okay, so either a is equal to 0, b is equal to 0, or both a and b are equal to 0. Because if you do 0 times 0, you also get 0. So to solve an equation by factoring, what we're going to do is we need to figure out what values make our equation equal to 0. So we've got some steps here that we're going to take. And the order, we're going to set the equation equal to 0. We're going to factor the polynomial if we can. We're going to set each factor equal to 0. We're going to solve for the variable, and then we're going to check our solutions. Okay, so that doesn't make a lot of sense yet, but let's look at some examples. So directions, solve each equation. Number 1, a minus 8, parentheses, times 5a plus 6, in parentheses, equals 0. Now, here's the nice thing. This is already factored. And it's already set equal to 0. So this is a situation, we actually want all the variables on one side. We want everything on the same side. We want 0 on the other side. So set the equation equal to 0, that's done. Factor the polynomial, that is done. Now what you've got here again, you have two sets of parentheses that are multiplying and giving you 0. So what happens is that either the first parentheses has to be your 0 or the second. So what we're going to do is we're going to take both factors here. I'm going to come down. Either a minus 8 is equal to 0 or 5a plus 6 has to be the 0. And so now we're going to solve each equation. So to solve for a, now I'm going to move negative 8 to the other side by adding it. And we get a is equal to 8. That's one solution. To solve this equation, we need to subtract 6 and then divide by 5. And now you can get a decimal for that. That's fine. That's negative 1.2. I'm actually just going to keep it as the fraction. So what happens is that we get two answers. We get two solutions here. And just to show you, the way that I would check this is I would go back to the equation, the original equation. Now let's say that a is 8. So I would do a minus 8 times 5a plus 6. Okay? Now you'll notice that this time I actually did put a time symbol in here just so I don't have a lot of parentheses. Now 8 minus 8 is 0. It doesn't matter what this is because 0 times anything should equal 0, which is the right side of the equation. So check, that's correct. How about negative 6 over 5? Well, I would do negative 6 over 5, subtract 8. And then the second parentheses is 5 times negative 6 over 5, plus 6. Now again, do I get 0? And the answer is yes. So both of these answers are correct for that. So the way that I check your solution, you take each number, you plug it back in. Does it make the equation equal to 0? If it does, then your answer is correct. I'm going to write this a different way. I'm going to write this as a set. Negative 6/5, comma 8. This is called a solution set. That's what the bracket, the squiggle bracket is. It's okay if you write it like this, but this is how I'm going to write my answers for these problems here. Okay, so it's not x comma y because it's not parentheses, it's a bracket, set bracket. 2 answers. All right, let's take number 2. Set the equation equal to 0. Good. Factor the polynomial. Now in this case, we have 2 terms. Is there a greatest common factor? Can we factor something out of these? Both of them have 3c. So we're going to factor out a 3c. 3c squared divided by 3c is just c. Negative 6c divided by 3c is minus 2 is equal to 0. Now, this is factored. Okay, we can't factor this anymore. Step 3, set each factor equal to 0. Now, we have 2 factors. We have 3c. So I'm going to say maybe that's my 0. Or c minus 2, maybe that's the 0, and then we solve. So this one we would divide by 3, and we get c equals 0. Here we would add 2, and we would get c is equal to 2. So here's our 2 answers. Now, do they work? Well, let's plug a 0 in. 3 times 0 squared minus 6 times 0. Well, both of these become 0, so 0 minus 0 is 0. Check. If we try 2, 3 times 2 squared minus 6 times 2. 2 squared is 4. 4 times 3 is 12. Negative 6 times 2 is negative 12. 12 minus 12 is 0. Check. So we have 2 answers, 0, comma 2. For our solution set. Okay, how about number 3? We have a trinomial equal to 0, so it's good, it's already set equal to 0. The reason why we want to factor is our goal is to get this situation, something times something is equal to 0. That's what we want. Okay, so as a trinomial, can we factor this? Well, that's a 1. 1 times negative 5, so remember, we multiply to get AC, we add up to get B. That's our goal. A times C is negative 5. So what multiplies to negative 5 and adds up to the middle, which is 4? Well, the only factors of 5 are 1 and 5. Now, to multiply to a negative, one of these has to be a negative value. Let's make this negative 1 and positive 5 because negative 1 plus 5 adds up to 4, and negative 1 times 5 multiplies to negative 5. This is our winner. Now, because this is a 1x squared, we can just write the factors x minus 1 times x plus 5. Now, this is an equation, so we're not done once we factored it. It's equal to 0. So either this factor is 0 or this factor is 0. Now we're going to solve. So we set each factor equal to 0. And so we'll go plus 1, plus 1. So x is equal to 1 is one solution. Minus 5 from both sides. X equals negative 5. Does it work? Well, let's take the original equation, the left side. So it was, let's see, let's plug in 1 first. So it was x squared plus 4 times 1, 4x minus 5. Do we get 0? Yes, we do. Perfect. And what if we plug in negative 5? So x squared plus 4x minus 5 also equal to 0. So it fits. Positive 1, negative 5. That's the answer. Okay, number 4. Let's see. Set the equation equal to 0. Right now it's equal to 12. So what we need to do is move the 12 to the other side by subtracting. So we get 2d squared minus 5d minus 12. Okay, you can't combine those. Equals 0. Now, this is a 2 in front. So 2 times negative 12, I'll put it on the side here, is negative 24. So what multiplies to negative 24 and adds up to the middle number, which is negative 5? The factors of 24, 1 and 24, 2 and 12, 3 and 8. Oh, 3 and 8. Now it has to multiply to a negative, and it has to add up to a negative. So I'm going to make the 8 my negative, and the 3 is the positive. 3 times negative 8 is negative 24. 3 plus negative 8 is negative 5. All right, now we can't go to parentheses yet. We're going to factor by grouping. 2d squared. I'm just going to write that as plus 3d minus 8d. That's our middle term. Negative 5d minus 12 is 0. Factor by grouping. Take the first pair. We can factor out a d. 2d plus 3 is left over. Now the second pair, they're both negatives. 4 goes into those. I'm going to factor out negative 4. And the reason, when we divide negative 8 by negative 4, we get positive 2d. Negative 12 divided by negative 4 is positive 3. And notice what looks really good is we have 2d plus 3. We have the same parentheses. We're going to factor that out. Now we have a factor times a factor is equal to 0. So we set each factor to 0, and we solve. And you're going to get d equals, we would subtract 3 and divide by 2. And here we would add 4. And those are our answers. So negative 3 halves, comma, 4. Okay, and then you can check. You can go back in and you can check, do these work? Now, I would plug it back into here, and what I'd be trying to get is the value 12 for that. So when I check negative 3 over 2, for example, I should get 12. Let me go ahead and do that. I'm going to type this a little differently. I'm going to store it for x, and that way I can just type 2x squared instead of d minus 5x. Does it give us 12? Bingo. Okay, so that works, and the other is going to work as well. Let's do one more here, number 5. This is not set equal to 0. I want my quadratic term, my squared term, to be positive, the coefficient, so I'm going to move the 16. So I'm going to get 0 equals 9s squared minus 16. Now, you can look at this as a trinomial and put a 0s in the middle, but this is a difference of 2 squares. This is one of those special factor patterns. So I'm going to do the square root of this. That's 3s, that's a perfect square, plus 4 times 3s minus 4 equals 0. And now we're going to take each factor, put it equal to 0. Let's go ahead and solve it. So we'll divide by 3. S equals negative 4 over 3 is one answer. And for this one, you'll do the same thing. You'll just add 4 and divide by 3. So you'll get S equals 4 over 3. When I write this answer here, one way that we can write it, instead of writing 4/3, negative 4/3, I'm going to write this as plus or minus 4/3. That means plus or minus. Those are my two answers. That's a short way of writing both of these, positive and negative. And again, if we check it, it's right. And that is the end of part 1.